A viewer named Marcus left a comment on our last investigation. He said he bought a 2003 Ram 1500 with a 5.7-liter Hemi in the spring of that year. He drives it every week. He tows a 24-foot travel trailer with it every summer. The odometer reads 281,000 miles. The engine has never been opened. Now compare that to the story of a man in Colorado who bought a brand new 2021 Ford F-150 with the 3.5-liter EcoBoost. He spent $58,000. At 97,000 miles, the turbocharger failed. The repair bill was $3,200. The dealer looked at him and said the same thing they always say now. It is not worth fixing. Put that money toward a new truck. How did we get from an engine that runs 281,000 miles without a wrench touching it to a $58,000 truck that is financially totaled at 97,000 miles? In this investigation, we're going to expose the turbocharger trap that Ford has been selling you as an upgrade, the cylinder deactivation disaster that General Motors engineered directly into the V8 itself, and the federal regulation that has already signed the death warrant for the American V8 truck. We are going to show you exactly why the smart drivers are buying the last ones right now before the window closes permanently. The first thing you need to understand is what they replaced the V8 with, and why. For decades, the American truck ran on a simple engine, the V8, 8 cylinders arranged in 2 rows, port fuel injection, spraying gasoline directly onto the intake valves, washing them clean with every combustion cycle. A naturally aspirated engine that breathed on its own, made power the same way at sea level or under a full load, and asked for nothing more exotic than regular oil changes. The 5.7-liter Hemi, the 5.3-liter LS, the 5-liter Coyote. These engines were not complicated. That was the point. They ran forever because there was almost nothing to break. But in the early 2010s, the government handed automakers a problem. The corporate average fuel economy standards demanded better fuel economy numbers across the fleet, and the Environmental Protection Agency test cycles rewarded turbocharged engines because small engines with turbos perform efficiently at the light throttle inputs used during government testing. They look great on paper. They look great in advertisements. The problem is that nobody tows a trailer the way the Environmental Protection Agency drives a car on a test track. Ford replaced the naturally aspirated V8 in millions of F-150 trucks with the 2.7-liter and 3.5-liter EcoBoost engines. They called it an upgrade. More horsepower, better fuel economy, the future of truck engineering. What they did not advertise is what a turbocharger actually is. It is a precision component, spinning it up to 150,000 revolutions per minute, driven by exhaust heat, and suspended on a film of engine oil thinner than a human hair. When that oil supply is interrupted, even briefly, the bearing fails. When you are towing a trailer up a mountain pass in July, and that turbo has been running at full boost for 40 minutes straight, the thermal stress on that bearing is nothing like what Ford's engineers showed in a press release. The class action lawsuit tells you what Ford knew. In the case filed in the Central District of California, plaintiffs alleged that Ford was aware of defects in the EcoBoost engine, including carbon buildup on intake valves, a problem that does not exist in port-injected V8s, and premature engine failures, and that Ford failed to disclose these defects to consumers. Carbon buildup occurs because direct injection, which EcoBoost engines use, sprays fuel directly into the cylinder rather than onto the intake valve. Nothing cleans those valves. Over time, carbon deposits accumulate, restrict airflow, and cause misfires and power loss. Cleaning them costs between $300 and $800 and needs to be done every 60,000 to 80,000 miles. On a V8 with port injection, this procedure does not exist. It is not a maintenance item. It is a problem that was invented when they removed the V8. According to a longevity study by IC Cars, trucks powered by naturally aspirated V8s are 23% more likely to reach 200,000 miles than equivalent turbocharged models from the same era. When the turbocharger on your EcoBoost fails, and at high mileage it will, the replacement cost runs between $1,500 and $3,500 at an independent shop. That is on top of the carbon cleaning you have been paying for every few years, and on top of turbo coolant lines and intercooler hoses that also wear and fail. The V8 owner pays none of this. They just change the oil. But the turbocharged V6 is not even the most cynical engineering decision made in the American truck market. General Motors managed to destroy the V8 from the inside. The General Motors 5.3-liter V8 was, for a long time, one of the most trusted engines ever put into an American truck. Simple pushrod design, nearly indestructible under normal use. Mechanics loved working on it because there was nothing exotic to fail. It powered hundreds of thousands of Chevrolet Silverados and GMC Sierras, and it built a reputation over decades for running well past 200,000 miles with basic maintenance. Then, General Motors had to answer to the same fuel economy regulations. Instead of replacing the V8 with a different engine, they decided to engineer a compromise directly into the V8 itself. They called it active fuel management. The idea was straightforward. At highway cruising speeds, when the engine does not need all 8 cylinders, the system shuts down 4 of them. The truck coasts on 4 cylinders, saves fuel, and posts a better EPA number. On paper, it sounds clever. In practice, it is the most expensive fuel economy solution ever inflicted on a truck buyer. Here is the flaw. To deactivate a cylinder, you need a special lifter, a component that sits between the camshaft and the valvetrain that can mechanically collapse when commanded by the computer. These are not standard lifters. They are engineered specifically for this system, with a small internal pin that holds them in their active position and releases to allow collapse. That pin fails. When it fails, the lifter can collapse at the wrong time, at speed, under load. The resulting debris, metal fragments from the destroyed lifter, circulates through the engine oil. It scores the camshaft and it damages other lifters. In the worst cases, it destroys the engine entirely. This is not speculation. The National Highway Traffic Safety Administration received over 14,000 complaints related to this specific failure on General Motors trucks. A federal class action lawsuit, Spearley versus General Motors LLC, filed in the Eastern District of Michigan, alleged that General Motors knew about this defect as early as 2011 and continued selling affected vehicles without disclosing it. General Motors issued technical service bulletins acknowledging the failure mode. They extended warranties on some affected vehicles. An extended warranty is an admission. You do not extend a warranty on a system that works. The repair bill, when this failure runs its full course, is between $5,000 and $12,000 for a lifter, on a truck that cost $40,000 new. The cruel irony is that this failure exists specifically because of active fuel management. Trucks without active fuel management, such as earlier 5.3-liter engines or 5.3-liter engines with the system disabled, have no comparable failure history. The standard lifter in an engine without active fuel management is a simple, passive component. General Motors took a reliable engine, added complexity to satisfy a regulatory number, and created a catastrophic failure mode that destroyed engines by the tens of the thousands. And if you think the solution is to buy a brand new truck with the latest technology and avoid the problem entirely, the Environmental Protection Agency has already decided what your options are going to look like. In March of 2024, the Environmental Protection Agency finalized what it calls the Phase 3 Multi-Pollutant Emissions Standards. The rule covers model years 2027 through 2032 for light-duty and medium-duty vehicles, which includes every pickup truck sold in America. The targets it sets for fleet-wide carbon dioxide emissions are not suggestions. Automakers that miss them face fines of up to $37,500 per vehicle sold in violation. The math is not complicated. A large displacement, naturally aspirated V8 engine produces more carbon dioxide per mile than a turbocharged 4-cylinder, a hybrid, or an electric motor. To hit the Environmental Protection Agency's fleet average targets, automakers need to sell large numbers of electric vehicles and hybrids to offset every V8 truck they sell. As electric vehicle sales fall short of projections, as they have across the industry, the V8 becomes a mathematical liability. The simplest solution is to stop selling it. Stellantis did not hide this. The company that owns Ram trucks publicly confirmed that the 5.7-liter and 6.4-liter Hemi Vibe 8 engines will be phased out of the Ram 1500 within this model cycle. The replacement is the Hurricane Inline 6, a turbocharged engine. Ford is pushing the F-150 Lightning and hybrid powertrains. General Motors is pressing toward electrification across its Silverado line. The turbocharged 6 is the transitional compromise, better emissions numbers than the V8, less range anxiety than an electric vehicle, enough horsepower to satisfy the spec sheet. But it is a compromise built around regulatory compliance, not around 200,000 miles of towing reliability. The window for buying a V8 truck from a major American manufacturer with a current generation body, current safety technology, and a factory warranty is closing in real time. The 2024 and 2025 Ram 1500 with the Hemi are among the final production years of that configuration. The 2024 F-150 with the 5.0-liter V8, not the EcoBoost, is available at dealerships right now. These are not collector cars yet. They are working trucks you can buy today at a regular price with a full factory warranty. That is the loophole, and it will not stay open much longer. So what does the smart money actually do with this information? First, understand what you are looking at when you walk into a dealership today. If you need a truck that will tow, that will work, that will run past 200,000 miles without a catastrophic repair bill, you are looking for one specific thing on the window sticker: a naturally aspirated V8 with no cylinder deactivation system. On a Ram, that means the Hemi, and you need to buy it now, in 2024 or 2025, because those are likely the final years it will be offered in the light-duty truck. On a Ford, that means the 5-liter Coyote V8, not the EcoBoost. Avoid the EcoBoost if you are going to tow. Avoid the turbo entirely if you plan to keep the truck for 15 years. If you already own a pre-2014 GM truck with the 5.3-liter and no active fuel management, keep it. That engine, properly maintained, will outlast almost anything you can buy new today. If you own a newer GM truck with active fuel management or dynamic fuel management, talk to a mechanic about a lifter delete kit. It is a documented solution that removes the collapsing lifters and replaces them with standard units. It exists because the failure is that well known. And if someone tries to sell you on the fuel savings from a Turbo 6 or a hybrid powertrain, do the math. A turbocharged engine that costs $3,000 to repair at 100,000 miles does not save you money. A cylinder deactivation system that destroys an engine at 80,000 miles does not save you money. The V8 that runs 280,000 miles on oil changes saves you money. This is not nostalgia. This is engineering reality. They are replacing a proven, simple, durable powertrain with complex technology designed to satisfy a federal test cycle, not to last the life of your truck. The final year of the V8 truck is not the end of an era. It is your last chance to buy the one that actually works. Do not let it close without paying attention.